Thanks for joining and welcome for another session of our Day One and Beyond webinar series, where we take you through various topics and activities related to building on an Oracle Cloud. Our topic for today is a quick start of the networking in OCI, where we will cover fundamentals of networking in Oracle Cloud and explore some tools available with an overview with several key resources. Now then, my name is Borna Shamlu. I'm a cloud engineer with Customer Enablement Team, and our expert presenters for today's session are Joey Hall and Ernesto Torres. With that, I'll hand it over to Ernesto.
Thanks a lot, Borna. Hello, everyone. My name is Ernesto Torres. I am a cloud engineer here at Oracle, and I will be kicking us off with this networking quick start session. Today we will be covering the following OCI networking services. So virtual cloud networks, or you'll often see them referred to as VCNs throughout the presentation, subnets, route tables, the different gateway offerings, our peering options, VCN security, load balancing service, and connectivity options. And by the end of this presentation, we expect you to be able to understand the core networking services within OCI, explain OCI VCNs and subnets, compare different networking gateways and their use cases, and be able to provision and deploy networking resources within your own tenancy. So let's get started. Oracle Cloud Infrastructure, or OCI, offers a comprehensive portfolio of cloud services to support running all of your IT in the cloud. You'll see an array of these cloud services available, but today we're solely focusing on the networking service. So when setting up your networking in OCI, these are the main components of our networking service that you should be familiar with to properly configure your network's behavior. We'll cover each one of these separately during the session, but I would like to just quickly list them out for you. So first we have the VCN, the Virtual Cloud Network, which is similar to your traditional data center, and it provides you complete control over your cloud networking environment without having to deal with the underlying hardware. So this is where all of your resources are going to be housed. Next, we have subnets, which are subdivisions of a VCN acting as individual units of configuration. Gateways, these enable traffic flow from one network to another. The load balancing service, which provides an automatic traffic distribution from one entry point to multiple servers reachable from your VCN. DNS, so the domain name system, which translates human readable domain names to machine readable IP addresses. And lastly, our Fast Connect, which is a high-speed, low-latency connection that allows you to access public and private Oracle Cloud services from your local infrastructure. So we'll get started with the VCN. So I'll build out these slides. I apologize about that. A VCN is a software-defined private network that you set up in OCI in a particular region. It is region-specific, and it has the same functionality as a physical network on premise. So it comes with your traditional firewall, rules for traffic, and rules for security. And just a refresher on regions. So a region is a localized geographic area containing one or more availability domains, abbreviated here as AD. And these ADs are fault-tolerant isolated data centers located within a region to achieve high availability. So the VCN would reside within a single region. However, it can cross multiple availability domains. Here in this diagram, we only show one AD just for simplicity. However, most of our regions do contain three. In the US, Chicago, Phoenix, and Ashburn are regions with three ADs, and San Jose is the only region with one availability domain. So when you deploy OCI resources, such as compute instances, the VCN is where they'll reside. And this enables communication with the internet and other instances, or your on-premises data center if you choose to. And each VCN has various components that directly affect the behavior of the network, such as gateways, security lists, route tables, just to name a few that we'll go over here shortly. And when you create one of these components, you must establish a relationship between that component and the VCN. This is required, or this will require the appropriate identity and access management policies. to grant permissions to both create the component and manage the VCN itself. However, to update components, you do not necessarily need permissions to manage the entire VCN. And the logical reasoning behind this is to grant least privilege to users, meaning you do not have to grant them access to manage the entire VCN in order to manage components of the network. Just be aware that giving an individual access to update particular components connected to the VCN could affect the overall behavior of that network. So now we're moving over to subnets, and this is a subdivision of a VCN. It could be either availability domain or region specific. Regional subnets are recommended. That means that any resource that you create in subnet D, for this example, you can allow OCI to select the AD that resource is going to fall into, or you could specify what AD you want them to reside in. I did mention that some of our regions may only contain one AD. If this is the case, we would still recommend a regional subnet because in the future, we may add more ADs to that particular region and the subnet would be able to take advantage of that resiliency. This is also important because for AD specific subnets, so subnet A, subnet B, and subnet C in this example, if their respective ADs were to go down, all of the resources will go down with that AD. Whereas with regional subnets, only the resources that reside in the AD that went down will go down, and you'll still have access to other resources within that regional subnet. Um, you can have multiple subnets in a single AD, and each subnet has a contiguous non-overlapping AP space, which can be either public or private, and you select that option upon creation. So when you spin up an instance, it must be placed inside of a subnet. It cannot just be floating around in the VCN. And every instance will have a physical network interface card that we virtualize and we call a VNIC, which is placed in the subnet of your choice. And your instances would draw their internal IP addresses from these subnets. The first thing you do when creating a VCN is give it an address space. So a VCN can cover one or more IPv4 CIDR blocks of your choice. However, you can also enable IPv6 either upon creation or you can enable it to an existing IPv4 only VCN. And you can see here that that a CIDR address looks like a normal IP address, except that it ends with a slash followed by a number. So the prefix is the representation of the network address in binary, while the suffix is the total number of bits in the IP address. So the number after the slash basically represents the number of addresses in the range. The lower the suffix in the VCN size range, the more IP addresses are available. And the allowable VCN size range in OCI is a /16 to a /30, where the VCN reserves the first two IP addresses and the last one in each subnet CIDR. So a /16 would be the largest size Oracle allows because it's generally sufficient for the number of nodes in a cluster, giving you a little over 65,000 network addresses, which is enough for a cluster of up to 512 nodes. And a /30 would be the smallest because it will only give you 4 IP addresses to work with. However, I mentioned that the first two IP addresses and the last one is automatically reserved. So in reality, you would only have one free IP address to work with. We do allow the CIDR block to be modified once you create the VCN. If you think you're not going to need all the addresses, you can lower that by decreasing the number after the slash, provided you don't have resources in that portion that you are reducing. So you can see here, the CIDR range for the VCN is a 10.0.0.0/16, and the subnets within that VCN get their CIDR notation from the VCN itself, and they do not overlap. We try to not get anything to overlap within your networking to avoid any issues. So now we're shifting focus to route tables, and each VCN automatically comes with a default route table that has implicit rules, which include the routes for VCN siders. And these route tables are used to send traffic out of the VCN to the internet, to your on-premises network, or to peer VCNs, whether that be in the same region or in a different region. And these routes have rules that look and act like traditional network rules, where each rule specifies a destination cider block and the target for any traffic that matches that cider. So the primary routing scenario is for sending a subnet's traffic to destinations outside of the subnet, right? So each subnet has a single route table associated with it, and all VNICs inside this subnet are subject to the rules in that route table. And these rules would essentially govern how the traffic leaving subnet is routed. So if no route rule matches the network traffic you intend to route outside of the VCN, the traffic is automatically dropped. If the route table has overlapping rules, it will use the most specific rules in the route table to route that traffic. And one important thing to note is that if you don't specify otherwise, every subnet will use the VCN's default route table. So just keep that in mind. Moving on to communication to the internet. The first gateway we'll be covering is the internet gateway. And this is pretty straightforward. This internet gateway provides a path for traffic between the VCN and the internet. And you could only have one internet gateway per VCN. So it's a one-on-one relationship there. And once created, in order to enable traffic flow, you must add a route for the gateway in the VCN's route table, and the hosts on both ends of the connection must have public IP addresses for routing. Connections that originate from your VCN destined to the to a public IP address goes through the internet gateway, and also connections that originate outside of the VCN destined to the public for a public IP address inside of the VCN also go through this internet gateway. The next one is the NAT gateway. So in comparison to the internet gateway, the NAT gateway would enable outbound connections to the internet and it allows it to receive responses. However, it blocks any inbound connections initiated from the internet. So it gives an entire private private network access to the internet without assigning each host a public IP address. So you can see here in the diagram that the subnet connected to the NAT gateway is private, but the NAT gateway allows it to access the internet, get a response, but it will block the inbound connections initiated from the internet. And this is all possible because when a host in the private network initiates an internet connection, internet bound connection, the NAT device's public IP address will become the source IP address for that outbound connection. And the response traffic from the internet therefore uses that public IP address as a destination IP address, and the NAT device routes the response to the host in the private network that initiated that connection. So sends it back to this private subnet. And the biggest use case for a NAT gateway is to retrieve updates and patches from the internet. Now, communication to your on-premises network would require a dynamic routing gateway, so a DRG. We see it pictured here in blue. And this provides a path for traffic between your VCN and destinations other than the internet. Your customer data center, on-premises networks, whether that be in the same region or not. So you can use it to establish a connection with your on-premises network via IP SecVPN. This essentially goes through the internet through private traffic by using encryption, or you have the option of using Fast Connect. And Fast Connect is the product name for the digital communication or the digital circuit communication that provides a private dedicated connectivity from your on-premises network to OCI. It's kind of like your own HOV lane, and the Fast Connect option will be covered later in the second portion of this presentation. But those would be your two connectivity options. VCNs and DRGs do have a one-to-one relationship as well, and in comparison to the internet and NAT gateway and the service gateway that we will cover here in the next slide, the DRG is a standalone object. So it's an attachment to the VCN. You create it outside of the VCN and then attach it. Whereas the internet gateway, the NAT gateway, and the service gateway are all created within the VCN. So if you were to terminate the VCN, unlike the internet, the NAT, and the service gateway, the DRG will not be terminated with it. So you will still have that attachment, and you can move it to a different VCN if needed. So the service gateway is the last gateway option that we'll be covering. This gateway lets resources in your VCN access public OCI services such as object storage, but without using the internet or the NAT gateway. And object storage has public endpoints, which allows you to access storage through the web, right? So you would want to access object storage because when you take backups of your database, the best place to store them is object storage, which is built for this massive scalability and reliability of data. So if you have a private instance and a private subnet and you do not want it to be exposed to the internet at all, you would use a service gateway to connect to the object storage public endpoints using your instance private IP address. And this is all possible because it bypasses the internet altogether and it allows your resources to remain within OCI's backbone network when communicating with the Oracle Services Network. So you're never leaving the OCI network to reassure that these aren't being exposed to the internet at all. And then lastly, peering connections. So with VCN peering, we have with VCN peering, we have both local VCN peering and remote VCN peering, and they do exactly what they sound like they do. So local VCN peering would be the process of connecting two VCNs in the same region, and then remote VCN peering would be the process of connecting two VCNs in different regions. And you could see here, this would be considered a local peering, so VCN1 and VCN2 being connected through a dynamic routing gateway in region 1, and then this would be the remote peering, VCN1 connecting to VCN3, both in different regions through two DRGs as well. So I will now quickly shift over to the OCI console to quickly demonstrate how to create a VCN. So you should all be able to see my screen. I am in the homepage of OCI. So the first thing you want to make sure is that you're in the correct region. So US Aspirin is the region my home region and the region I want to deploy this VCN. Keep in mind, if you deploy a VCN in a different region, you would not be able to move it from region to region. However, if you create it in the wrong compartment, you will be able to make that move and move to a different compartment within the same region. So we'll navigate over to this hamburger menu on the top left, go to networking and virtual cloud networks. Here, I will. So you have two options here to create a VCN. You can create a VCN manually, or you could use the wizard. So I will show the wizard and show you how easy and quickly you can have a VCN up and running. So I'll click Start VCN Wizard. It gives you two connection types. The first being VCN with internet connectivity. You could see here the architecture diagram of what's going to be deployed and what's included right here. So the VCN will be deployed. You'll get a private and public subnet. The three gateways that we discussed, internet gateway, NAT gateway, and service gateway. And then you also have the site-to-site VPN to connect to your on-premises network. Essentially, it would create just about everything except for the NAT gateway, and then it would also sub as a site-to-site VPN to connect to your on-premises network. I will go over the internet connectivity option because we're not connecting. We won't showcase a connection to your on-premises network in this demonstration. So I'll go ahead and select Start VCN Wizard here. And basically, it will just ask you for basic information. Disregard the limits warning here for my tenancy, but again, it shows you the architecture diagram and what's going to be deployed. So the basic information, you would give it a VCN name. So for this demo, I'll call it Wizard VCN. The compartment you want it to be deployed in. You can see here that our root compartment, in our root compartment, we have a couple of child compartments and then child compartments within child compartments. Keep in mind that compartments can be nested up to 6 levels deep. I am in the current compartment. I want to deploy it. So infrastructure, you would give it a CIDR block range here. I'll leave the default that they gave me. So this will give me about 65,000 IP addresses. This is the biggest size VCN that you can create in OCI. And then you also have the option to enable IPv6 if you like. You can enable it now, or you can enable it after creation of the VCN. Below is configuring the public and the private subnet that's going to be deployed as well. So it already gives it a CIDR block range within my VCN CIDR. So a /24 and the 1.0/24 to make sure these do not overlap. I don't have the option to give it a name for the public or private subnet through this wizard. However, it gives it a nomenclature where it names it the name of the VCN. So you will see it's going to be called um, Wizard VCN/public subnet, and then private subnet for that one as well. And you'll see it before you deploy it. And then lastly, you have the option to add tags if you're looking to tag the VCN. I will bypass this option for this demonstration, and I'll hit next. And then this is just to review and create, make sure everything's correct. So the name of the wizard, the compartment is going to be deployed in. Any tags, if you added tags, the CIDR block range, the DNS label, and the DNS domain name. And then below here, I had it mixed up. So it's public subnet / wizard VCN. So the name of your VCN goes at the end, and you can see the same nomenclature for the private subnet, along with its CIDR block ranges, and then the security list and route tables associated with both. And then lastly, it shows the gateways that are being created. So internet gateway, NAT gateway, service gateway, tells you which subnets are going to be using what. So public subnets will be using them. And then here are the names it gave it. So same nomenclature again, the name of the service, and then followed by the VCN's name. Below are the security lists. So it's attaching this default security list with a couple ports pre-populated for you. So port 22, so you can SSH into it, and ICMP ports that are generally used for troubleshooting purposes, but you could go in and modify these, delete them upon creation. Really easy to do. And we'll go more into security lists in the second portion of this session. And then also the route tables. So the route tables are used to communicate outside of the VCN. All right. So the default route table will have the internet gateway with the quad 0 port open. So open to the internet, open to the world, which is what the internet gateway requires. And this default route table would be attached to the public subnet, of course, because the public subnets would have those public IP addresses. Both the host and the destination must have public IP addresses. And then the the route table for the private subnet would have the NAT gateway and the service gateway, because we do not want the internet to be able to access these subnets that are being attached to these route tables. Once I see everything is good, you would hit create. And within seconds, it would create it for you. I won't hit create just because we have one created already that I would like to go through. I believe it's called Demo VCN. And here you would see the VCN information. So again, the compartment one is created in the OSID. So OSID is an Oracle Cloud ID, and every resource you create inside OCI will have a unique OSID in order to reference that service. And here we have the IP administration. So the CIDR block range that it was given. Sorry, here. So these are the IP CIDR ranges, and this is the number of IP addresses available. So a bit over 65,000 DHCP options. Then if I were to go to subnets, here are the two subnets that were created as well. So the private and public subnet, if they were named differently, you could see the subnet access on this side, and they are regional subnets. They're not AD specific. Here you can go into each specific one to see its specific details. Again, it has its own unique OSID ID as well. You can see more details on it on that specific subnet too. IP administration, security, monitoring, and tags. Same thing goes for the public subnet. And now we'll quickly go through the gateways. So I'll go over the dynamic routing gateway at the end. Here is the internet gateway that was created, and then the NAT gateway and the service gateway as well. And if we had any local peering gateways using the DRG, they would be displayed here. But for this demonstration, we are not showcasing that. Routing. So here you will see the route tables, security lists, and network security groups that Joey will be covering here in a sec. So these two will make more sense in a few minutes. But going back to gateways, in order to create a routing, you see here it's routing a DRG attachment. It's not a DRG gateway itself. So you would first have to go outside of the VCN, networking, and it should be dynamic routing gateway, so customer connectivity. You would go here, and then this is where you would create the dynamic routing gateway. You would give it a name, the compartment you want to create it in, and then tags if you're looking to tag that resource and create that gateway. So I won't create one, but once you create it here, it would be listed here, and then you would simply just go back to your VCN, Virtual Cloud Network, demo VCN, then go to gateways. And then here you would create a DRG attachment. So you would give that attachment a name. You want it from the DRG is in your local tenancy, another tenancy if you're doing a remote peering connection, and then you would choose it. So since I don't have any created, it's grayed out. But if I would have created that DRG, I would be able to select it here and then create that attachment for this VCN. So that was a quick demonstration going over all of the resources we covered in the PowerPoint. The only difference from creating the wizard, from creating a VCN to the wizard and creating it manually, when you create it manually, you would only get the VCN itself. You would then have to go into the VCN and create the subnets of your choosing, and then create the gateways as well. So it's a bit more tedious, but if you like the manual process and like doing it yourself, that is the option to go with. However, if you're looking to spin up a quick VCN to get started, then the wizard would be the easiest and fastest way to doing that through the console. That covers this demonstration. Just to stay on time. I'll go ahead and pass it over to Joey so he could cover the second portion of this session.
Perfect. Thank you, Ernesto. Can you hear me okay?
Yep, perfect.
Awesome. So now that Ernesto showed us how we can set up the framework for our networking infrastructure, we can start to configure some of those pieces that were provisioned, and we can add on additional pieces as well. And the first area that you might want to configure is going to be some of the virtual cloud network security features, specifically the different firewall options that you have. That was shown really. You had the base rules that were added when Ernesto did the VCN wizard there. But you're going to want to add additional ones as you start to create different resources and have traffic going in and out of your virtual cloud network. So the first type here is going to be your security list, and that's going to consist of rules that specify the types of traffic that are allowed in and out of the subnet via these ingress and egress rules here. This is going to be present for any subnet that you create, and it's going to be added as well as a network security group that you will get to configure as well. If we look at the differences between the two, you could see security lists here on the left, and this is going to be subnet specific. And you'll have network security groups on the right, which is going to be specific to a group of instances or VNICs. So here, the rules that I create, the ingress and egress rules, will apply to all instances within that subnet. So here, if I have a security list for this subnet, both instances in here would be subject to those rules. Similarly, for the other subnet, just this one instance would be subject to those rules. That would differ from your network security group because you could have the same set of rules or the same security posture for instances that may reside within different subnets or different sections of your virtual cloud network. So here, if we labeled these servers A, B, and C, server A and server C could now be a part of the same network security group, even though they are residing within different subnets. And then server B would have its own network security group where it has ingress and egress rules that it is subject to. So you can use either or, you could use both. We suggest using network security groups because they are going to be more granular. And if you do end up using both for some reason, just remember it's going to be the union of the two. So if it's allowed in one, it's going to be allowed in both. But typically we recommend utilizing those network security groups, which you can configure after you've gone through that wizard that Ernesto showed us there. Now, one of the components that gets provisioned is going to be the OCI load balancer. And this is going to help automate traffic distribution from one entry point to multiple servers that you have reachable from your virtual cloud network. And this can do things like help improve your resource utilization. It can help you facilitate scaling. It can ensure high availability as you route traffic across different availability domains. And you can configure a bunch of different policies that can help you run health checks on your servers to make sure everything's running okay. You can distribute to overloaded instances to other instances to balance out your application traffic and make it more efficient to run. It's good for disaster recovery as well. If something goes down, you can route traffic to another server behind there, and that's what some of these health checks are going to be useful for. And then the way in which you also route that traffic is going to differ based off of the type of algorithm that you use. So you could do something like IP hash, you could do something like round robin. So depending on how you want to route the traffic to your servers, you'll be able to configure those algorithms after or during the provisioning process. You can also create the public load balancers, so a load balancer that has a public IP address associated with it, so that's accessible from the internet. Then you can also create private load balancers, which is just going to have an IP address from the hosting subnet. So when Ernesto went over the subnet section, right, whenever you provision something within that subnet, that resource will draw its internal IP address from the subnet that it is placed in there. Then you can also configure multiple listeners here too. So for an IP address to load balance transport layer 4 and layer 7 traffic. And both public and private load balancers can act as reverse proxies and route data traffic to any backend server that's reachable from your virtual cloud network. If we look at a quick diagram here, you can see we have an active and a failover load balancer, each of them residing in a different availability domain. We are utilizing a regional subnet for this, right? So we can have these load balancers be a part of the same subnet, even though they are residing within different availability domains. This is our load balancer pair, and we have our listener there for that as well. And then we have the backend set down here, consisting of backend servers for each of these. So backend server, that's just application server responsible for generating content in reply to any of the incoming TCP or HTTP traffic. And the set is just the logical entity for the multiple servers, and that's going to come along with that load balancing policy, health check policy, and determines how you're going to direct traffic between that collection of servers. It's good to have the active failover pair here as well to get some of those benefits that we talked about in terms of high availability, disaster recovery, scalability, and all of that. The next piece we're going to go over is the OCI domain name system, or DNS. So a little background on DNS. The DNS service is basically here to help you create and manage your DNS zones within OCI. So a DNS zone is just a part of the overall DNS namespace, and then the SOA defines a DNS zone within that namespace. And what that namespace is going to do, or name system is going to do, it's going to translate the domain names into machine readable IP addresses, and then vice versa to get the response back to you. And depending on if you're going to be doing a public DNS or a private DNS, which you can provision either or depending on your use case within your environment. The service within OCI is highly available. You can use it for your primary or your secondary internet-facing DNS, and then it's going to allow you to distribute that traffic across multiple regions based off of a variety of different policies that you can set up to direct that traffic. So it could be based off of location or other things as well that we'll go over here in a second. And it's going to offer a complete set of functions for zone management. So as mentioned, we'll be able to create and manage these zones and records. We can import and upload our zone files. We can filter and sort the views of the zones and those records. Secondary DNS zone support, so for redundancy there. And then accessing and utilizing DNS zones and all of their features via the APIs or any of the SDKs that you're going to be using. As mentioned, you could do a public DNS, so that's creating zones with publicly available domain names reachable from the internet, and that you will need to register with a DNS registrar, versus a private DNS, which you can also create. That'll provide the host name resolution for applications running within your virtual cloud networks or between virtual cloud networks. We'll take a look at private DNS here next. So this is just going to be an example there. So whereas that public DNS creates zones available and reachable from the internet, the private DNS will create those domain names that you specify, and you can fully manage those zones and records within and between virtual cloud networks, and also on-premise or other private networks as well. If you look at the diagram here, it might be a little hard to read because we've got a lot going on it. You can see we have some private DNS views, so that's a collection of private DNS zones. And then we also have private DNS resolvers within here as well. So that's going to have a dedicated private DNS resolver, which will contain the configuration that serves responses to, and a couple of ways in which we can utilize both load balancers and some of the features of the DNS service. We can route traffic many different ways. So load balancer, we have the global load balancer, which we can use round robin load balancing to distribute traffic among multiple servers. You can split it evenly among endpoints, or you could do a weighted version for this as well. So you can specify the ratio when you distribute traffic between those backend servers. You can do failover, so active-active failover between two public assets. We can monitor the private endpoint via those health checks that we talked about, and then we can reroute all the traffic to the failover location if something happens to that primary that was initially set up. So that's kind of the diagram we went over earlier. Geolocation steering, so this can be based off of the location of the source query, and we can dynamically route those requests based on the physical location of it. And then ASN steering, that's based off of the autonomous system number, and the IP prefix steering routes it based off of the originating IP prefix. So you can utilize all of these to get the traffic to where it needs to go in a more automated fashion. Ernesto also briefly touched upon a couple of these when we were going over the initial VCN architecture. So when we talked about utilizing something like a dynamic routing gateway, the type of connection that you have to the DRG, and you can do via VPN Connect or Fast Connect. So we saw that previously. But diving into these in a little more detail, so you have public internet connection to OCI. You can set up VPN Connect or IPsec VPN. You'll have the OCI managed VPN service, which is free, or you could do a software VPN running on OCI compute for this. And then you can also choose Fast Connect for that dedicated private connection. And then you have a choice of different port speed and bandwidth options for that. If we look at site-to-site VPN, or previously referred to as VPN Connect and IPsec VPN, like you saw on that last slide, this is going to help you provide connection between your on-premise network and your virtual cloud networks. And this is going to have tunnel mode, which is supported by Oracle. So that will encrypt and authenticate the entire traffic packet that's going through. And then after encryption, the packet will be encapsulated to form a new IP packet that has a different header information afterwards. And when you set up IPsec, when you set up an IPsec connection, it's going to consist of multiple redundant IPsec tunnels. And for any given tunnel, you can either use BGP dynamic routing or static routing to route that. Now, this is going to differ from Fast Connect here, where you do have that dedicated private connection. And based off of how you set up Fast Connect or what you are choosing to connect Fast Connect with, you can utilize public peering, which is going to connect to public OCI services. You can see one of those being object storage here. Or you could utilize private peering, which is going to be the most common use case, where you will be connecting to a virtual cloud network within OCI, and that would attach to a DRG, one of the gateway options that Ernesto went over earlier. If you do choose to utilize private peering, you're going to have access to all of the public OCI resources that are supported by the service gateway as well. If you need to see a list of what those services are, we can send over the service gateway public services documentation for you to see that. But it's going to be the same for public peering as the service gateway access. So this is just showing difference between the two. So use case, right? Connecting to virtual cloud networks versus connecting to public OCI services. Typical bandwidth, similar there, same protocols. Difference here is going to be for the point-to-point IPs. The customer assigns these for private versus Oracle assigned for public. Similarly, if we look at the limits, they're going to be different as well. Higher limits for private, lower limits for public and then different ASN requirements there too. Now, with the time we have left, I'm going to hop into the console to show you how you can visualize some of these components once you have them provisioned within your environment. Okay, so we're back into the OCI console. And if we go up to the top left navigation menu here, we go down into networking. You'll see under Network Command Center, there's something called the Network Visualizer. We can just go into the Network Command Center as a whole to show some of these components as well. But this is going to give you different features to help you visualize, monitor, and troubleshoot your network within OCI. So if I want to view resources within my network, if I want to look at troubleshooting different network logs, VCN flow logs, if I want to go through and check status on some of my servers, I can do all that with a more visual representation within here. So going into Network Visualizer, you can change the compartment that you're looking at here. If I choose a compartment that's higher up in the hierarchy and I include child compartments, this diagram is going to get busier and busier. So try to navigate directly to the compartment where that resource is going to be located, because even in our infrastructure compartment here, you can see we have a bunch of different VCNs that people are using for different demonstrations and environments. But we can drill down into one of these. You can see each of these hexagons represents a virtual cloud network that we have provisioned within this compartment in this region. Okay, so you do need to have the correct physical location. So in this case, US East Ashburn, and the logical grouping via the compartment. So both of these need to be correct for you to be viewing the appropriate resources. So if you can't find something, either A, you don't have permissions, or B, you don't have the right combination of these two aspects here. You can see on this VCN, we get the overall CIDR there at the top. And then we have the different gateways that are provisioned on this virtual cloud network. So not a ton of information at this level, but we can always drill down further into these. So if I click on this virtual cloud network, I can get some of the information about it. So it's OCID, the name. If I want to go to the page for this virtual cloud network, like Ernesto showed after he provisioned all of those resources, I could just hyperlink here. It would take me directly to that page where we can see all of the resources specific to it. You can see the state, you can see the route table associated with it, as well as the DNS domain name. But the more interesting piece here is going to be these resource maps. So I could choose to look at the routing map, or I could choose the VCN security map. The routing map is going to be most related to the route tables that Ernesto went over. The security map is going to be more related to the VCN security firewall components that I went over, which were the security lists and the network security groups. So let's say we go into the routing map. Into the diagram, and now shows which routes are available or that you have currently added to your route tables designated by these lines here. So you can see I have a route connecting my NAT gateway to this private subnet and the service gateway to this private subnet. And then I have another route here from my internet gateway going to the public subnet here. And I can click into either of these to see an inventory on what's within these subnets. So you see public will house my load balancer, and then private is going to house my backend sets, because that's how we have the architecture set up. So let's look at public first. And here you could view the subnet inventory. So let's go into that. Inventory just stating what I have provisioned within this subnet. You can see load balancers, instance pool associated with that load balancer. Click on the load balancer, active. I could do a path analysis for this as well, and I could view additional resource details. Again, if I wanted to navigate directly to this load balancer, I would just click the hyperlink with the name. Now, if we go back to our private subnet, see the private subnet up here. Same thing, we can go into the inventory map. And it shows the 2 servers that we have provisioned within our private subnet. Again, you'll get information about each of them here. Make sure they're running. I can see the status of these via health check of my load balancer that I saw previously as well, or I could go directly to the servers in the visualizer here. I'm going to go back up a couple levels for the last piece here. So we looked at the routing map. Quickly go into the security map for it. So ECM security map. You can see here, you have your security list. So it's always going to be one-to-one to your subnet. So every time you provision a new subnet, you're going to have a new security list associated with that subnet that'll be connected here. So there's one for private, here's one for a database subnet, here's the one for our public subnet. If you make any network security groups, either none in this one right now, but you'd have those provisioned here. If these aren't provisioned by default, they're not going to show up when you use the wizard like we did for this. But you could create your own and they would show up here. They're not going to be associated with the subnet because they are not subnet specific, as we remember from the slides. So you'll see them. If you could click on them here, it would show which instances are associated with that network security group. Versus here, you could just see how it's associated with the subnet that's with. This is a good way for you to get an overall view of what your network looks like, can help you view connections, can help you see how your route rules and your security lists are functioning and make sure everything is connecting appropriately, and get a good high-level view on the status of the different resources that are provisioned as well. So a couple of things to remember before I pass this back to Borna to close it out, so we can get to some of the pending questions if there are any. A couple bullets to remember. So a virtual cloud network is a virtual private network that you set up within Oracle data centers. Subnets are divisions of that virtual cloud network that you define. That's going to contain the network interface cards, which are attached to the instances. And each subnet consists of a contiguous range of IP addresses. The virtual cloud networks have built-in firewall rules applied at the subnet level called security lists, but you can also do it at the VNIC level or group of VNICs utilizing the network security groups. The load balancing service will help distribute traffic across multiple servers within your backend set, and you can connect to your virtual cloud network over the public internet through a VPN using site-to-site VPN Connect and through Fast Connect for that dedicated private connection. So just a couple things to remember, and I will pass this on to Borna to see some of the additional resources we have for learning more. So Borna, over to you.
Awesome session. Thank you, Joey and Ernesto. Really appreciate your time and help with this session. I hope it was a good learning experience for everyone involved. As far as wanting to learn more, here we have additional resources available to further education enrichment that you can take advantage of. Now, if you enjoyed this session and would like us to conduct personalized training sessions for your organization, please do email us at our personal training email and we will reach out to you. If you want us to conduct just a hands-on lab, we have our newly designed QuickStart Live Labs for a more expedited hands-on learning towards a particular topic. Under the Code Innovate program, we can help co-develop a solution for you based on your own use case. Now, please remember that personal training is an investment, and we make it for our customers to help them grow and develop their OCI skills at no extra cost to them. And these are the webinar series, other webinar series under our Day One and Beyond program, where we keep adding sessions on training topics. Please do take a moment to review the other series and webinars to learn more about Oracle Cloud. And also, please don't forget to visit our Day One and Beyond page and register for the next session if you're ever interested. We also recommend bookmarking that Day One and Beyond page and checking frequently for any new sessions on training topics that may come up. Now, with that said, thank you again for joining us, and we will see you all next time. Have a great day, everyone.